Okay, in this video I will be showing you how to solve exponential equations. So let's go ahead and get started. So first of all, there's a property that we're going to use here. Notice b to the m power equals b to the n power if and only if m is equal to n. So in other words, if you look here, you have the same base. And if b to the m power is equal to b to the n power, the only way these two exponential expressions could possibly be equal is if m also equals n. And so we're going to be using that idea. Now this property actually goes both ways, but that's the direction that we're going to be going. Alright, so let's go ahead and get started. So we have 4 to the x power equals 64. And of course, x is 3. I would expect you to know that 4 to the third power is 64. So we don't really need the property here, but I'm going to show you how we use it. See, when I look at the 64, I recognize that I could write 64 also with a base of 4, or as 4 to some power. And so we could write 4 to the x is equal to 4 to the third power. So now we're going to use the property. Since our bases are equal, both of them are 4, we know that the exponents must also be equal. So let's set the exponents equal, and we're set. Now again, this is not all that helpful here, but with some of the problems we do, it's not as obvious what the solution is. And so we'll use this technique. It'll be a little more useful. All right, so for number 2, we have 3 to the 2x power is equal to 27. All right, so notice we could write 27 as 3 to a power. And so once again, we can use the property. We have equal bases, so the exponents must be equal here. So we'll set 2x equal to 3. And when we solve, we'll divide by 2, and we get 3 halves. Now, one of the things I want to show you is, first of all, it's a good idea to always check your answers when you're solving equations. However, the other thing is these are pretty easy to check, and what I found is for students that check their answers when they're solving exponential equations and logarithmic equations tend to do pretty well on the test that tests you on those topics, or at least on that part. Let's look at number 3. Actually, I'm sorry, let me finish checking here. So we have 3 to the, notice it's 3 to the 2x, so it'll be 2 times 3 halves power equals, well, that would be 3 cubed, because notice the 2's cancel here. And of course that is 27, and so this does check when we plug in 3 halves into this equation here. Alright, now let's move on to the next problem. So we have 2 to the 3x minus 1 power is equal to 16. So if you haven't already, I would encourage you to try to do this one and then watch the video. Alright, so notice 16 can be written as 2 to a power. It would be 2 to the 4th power. And so again, we can set our exponents equal. We get 3x minus 1 is equal to 4. And let's see, we'll want to add 1 to both sides. We get 3x equals 5. Divide by 3. And so our answer is 5/3. So again, let's go ahead and check this. When I plug 5/3 into the equation, again, I'm plugging it into the original equation. Notice 3 times 5/3, well, the 3's cancel there, and you're going to get 5 minus 1, that's 2 to the 4th, equals 16, which of course is true. All right, let's move on. So we're going to end up having 2 methods for solving exponential equations, and the first one is what I call the equal bases method. So we're going to talk about another method next. So for exponential equations, we're going to have 2 approaches that we'll use. The first one is this equal bases method, where we get the 2 exponential expressions to have the same bases, and then we set the exponents to be equal, and that's how we solve for x. All right, so let's go ahead and move on to the next problem. So I've already put up there equal bases. That's the first technique. And now we'll discuss the next one. So here it says solve, round to 3 decimal places. So the first thing hopefully you notice here is you can't write 40 as 2 to some nice power of 2. Or I should say 40 as some power of 2. Yeah, I mean, and using a nice integer value. So because we can't do that, we're not going to use the equal bases approach. We're going to use something else. So I would encourage you to think about what we've already learned. We've worked with exponential equations before, and consider what you might do as a first step here. All right, so hopefully you thought, oh, you know what, I could switch this to logarithmic form. In fact, that's one of the things we learned is anytime you're trying to solve for x and x is in the exponent, you're going to want to solve, or you're going to want to change to logarithmic form to start. So let's go ahead and do that. Let's write, actually, so this is the change forms technique. So we're switching forms or changing forms from exponential form to logarithmic form. So this, we'll write log. Our base is 2, so that's our subscript. The 40 goes here, that's the answer. And the exponent goes all by itself. Remember, it's base, exponent, answer. 2 to the x power equals 40. So you can see this is correct. And then this is not a base 10 log, it's not a common log, and it's not a base e log or a natural log. And so we're going to want to use the change of base formula to simplify this. This is the log of 40 over the log of 2. I think of it as the log of the higher number over the log of the lower number. All right, so when you put that into your calculator, by the way, notice I used the parentheses around these numbers. It's a good idea to do that when you put these into the calculator if you want to avoid making a mistake as far as entering it into your calculator. Now I want to remind you that checking your answer is a good idea. Let's go ahead and do that here. So 2 to the 5.33 or 322 power is equal to 40. If you plug that into your calculator, you see that it works. All right, let's look at the next problem here. So we have 19 to the x power equals 143. This is just like the last problem we did, so I would encourage you to give it a try and then watch the video. All right, so let's see, let's write it in log form. It'd be the log base 19 of 143 equals x. And we can now write that using the change of base formula. It'd be the log of 143 over the log of 19. Notice we're going from a base 19 log to a quotient of 2 base 10 logs, which we can easily enter in our calculator. And we get 1.685. And again, we can check our answer. 19 to the 1.685 power should equal 143, and you can verify that it does. By the way, when I give you a chance to work on problems, I'm assuming you're just stopping the video. I'm not trying to give you enough time because I'm trying to keep the length of the videos as short as possible. All right, let's move on to number 6 here. So here we have e to the x power is equal to 28. Again, I'd encourage you to try this one first. So it turns out to actually be pretty simple as long as you're comfortable switching forms. So for some people, I'll do this step here. I'll write log base e of 28 equals x, but that's not how we write our natural logs or base e logs. We use ln, so it'll be ln of 28 equals x. And that's one of our logs that's on the calculator. You can put that into your calculator and you get 3.332. And so when you check that, you can verify that that does work. All right, let's move on to number 7 here. Now, I would encourage you to try this one. It's similar to the one we just did, although there's some extra steps. And the first step is going to be really key. So let's see what you see and then watch the video. Okay, so here's the thing. This 1,000 is like an extra number that's in the way. We have base, exponent, and answer. Those are our three parts of an exponential function, or what I call the basic exponential function. And so we need to get rid of that 1,000. Now notice it's 1,000 times e to the negative 4x, and so all we need to do is divide. And so we get e to the negative 4x power is equal to 0.075. So now you have the three parts, base, exponent, answer. And so we can go ahead and switch forms. So it'll be the log base e of 0.075 is equal to negative 4x. Again, you can check this by doing the around the world thing. E to this power equals that. And of course, that's what we have here. And so now the other thing is this is kind of an optional step. You may have just gone directly to this step. Sometimes I'll put a little e in here to help me to do the translation or to switch forms. But now we are one step away. All we need to do to get x by itself is, since it's negative 4 times x, we'll divide by negative 4. And so x is equal to this quotient, natural log of 0.075 divided by 4. You want to make sure you put this in with parentheses around this part here. And you should get 0.648. So it's a little bit more work to check this one, but you can verify that it does work. I'm going to let you do that. Let's go ahead and move on to the next problem. All right, so this actually looks very similar to some of the ones we were doing earlier. I want to show you this a different way because we're going to be using this different approach for a more challenging problem that we're going to do next. So first of all, instead of rewriting this in log form, which is my own personal preference for solving this, because I just think it's so important that you're comfortable switching back and forth between exponential and logarithmic form. In fact, when you're solving exponential equations, it's frequently useful to switch to log form, and when you're solving logarithmic equations, it's often useful to go the other direction, change to exponential form. But we're going to do something a little different here. We're basically going to use our basic fundamental skill that we use with equations. Whatever you do to one side, you do to the other. And we're going to go ahead and take the log of both sides here. Notice these are both base 10 logs. And so I'm just basically taking the log of each side, base 10. Now we got to remember there's a property of exponents that we can utilize here because we're trying to solve for x here. So it would be the power rule. If we have the log of a power, which is what we have right here, we can move that x out front. So let's go ahead and do that. And then on the other side, we just have log 13. Now we have x times the log of 5, so this is multiplication. Now keep in mind the log of 5 stays all together. I mean, we don't write the base, but it's understood to be a 10 there. But this is a value, and we treat it like a single number. So we're just going to divide each side by the log of 5. And so finally we end up with x equals the log of 13 over the log of 5. Notice I put in the parentheses there because we're going to put this into the calculator, and when we do, we get our answer. Actually, I rounded to an extra decimal place there. So I guess that would be a 4. Just fix that. And so when you plug that into you can check yourself by plugging that into your power, and you can verify that it worked. I had put 4 decimal places, but it really doesn't matter. Either way, you'll see that it's pretty close to 13, close enough that you know that you did your work correctly. Because we're rounding, it's not going to be exact most of the time. It might be like 13.00 or 12.99, but it'll be close enough that you know that it's right. Let's move on. So here we have 3 to the 2x minus 1 power is equal to 5 to the x power. Notice I can't use the equal bases concept because I can't get it so that we have the same bases. And there's nothing that we did previously that we could use other than what I just showed you. And we're just going to go ahead and take the log of both sides. All right, so you can see we have, now that we've done that, we can do like we did in this last problem. Whoops, let me switch colors here. We can move these exponents out front. And so let's go ahead and do that using our power rule for logs. And we get 2x minus 1. Notice it's a binomial, so I need parentheses around this because this is 2 terms multiplied by a single term, which is log 3, which again stands for some number. And then on the other side we have x times the log of 5. Now on this side I need to distribute. I'm basically going to multiply the log 3 times each of the terms here. So let's go ahead and do that. We're going to get 2x times the log of 3 minus 1 times the log of 3, or minus log of 3. And of course the other side is the same. Now we're trying to solve for x, so I need to get these terms that have an x in them on both sides. And so I'm going to do it in a couple of steps. And by the way, I want to get rid of this term and get it on the other side, on the right. So I'm going to do it in 2 steps, although you really could do it in 1. It doesn't matter, you can just take 1 step if you prefer. So I'll go ahead and add log 3 to both sides. I get 2x times the log of 3 is equal x times the log of 5 plus the log of 3. And again, I need to get this x term on the other side. So let's go ahead and subtract x times the log of 5 from both sides. And so we end up with 2x log of 3 minus x log of 5 equals the log of 3. Now notice for these 2 terms I have a common factor. It's my only common factor for these 2 terms. It's x. And so I'm going to factor out an x on the left side, a GCF of x. This becomes x. Let's see, I need times 2 log of 3 minus log of 5. So if you distribute here, you get this. If you distribute here, you get that. And so on the other side, we're going to have just log 3. So finally, we're able to get x by itself. We're going to divide by this binomial here, since it's multiplied times x. And so we'll do it on both sides. Now I know this looks kind of complicated, but it's not too bad to put into the calculator and get a decimal answer. So we end up here with the log, x equals the log of 3 over 2 times the log of 3 minus the log of 5. Now when you put that into your calculator, because there's 2 terms in the denominator, you're going to want to make sure that you put parentheses around the denominator. And the other thing you should do is put parentheses around the 3 here. And so when you put that in your calculator, you should get about 1.869. When you go to check yourself, so we're basically going to use this equation here and plug in this x value. So let me go ahead and do that. When you check, when you put this into your calculator on the left side here, you get 20.25. And when you put the right side into your calculator, you get the same thing. And so that verifies that this is the correct answer. All right, there's one more problem I need to get you started on where you're going to be using your calculator. It's this one here. Number 10, solve e to the x plus e to the minus x equals 5 to 3 decimal places. All right, so we're going to take advantage of our calculator to help us solve this. So here's what we're going to do. First of all, we want to get 0 on one side, so let's get rid of this 5 by subtracting 5 on both sides. Now, what we're going to do next is we're actually going to put y equals this quantity here into our calculator. So we're going to graph y equals e to the x plus e to the minus x minus 5. So basically, this value is equal to 0 on the graph where we find our x-intercepts. Because remember, the height of the graph at those x-intercepts is 0. And so that's what you're going to want to do next is on your calculator, find the zeros which are at the x-intercepts of the function. Now I'm going to go ahead and make a video where I'm doing the work on the calculator so you can see how I get the answers here. But you should get negative 1.567 and 1.567. Remember, we're supposed to round to 3 decimal places. So I'm going to go, like I said, I'll make a video of how you would do that on your calculator. But we're all done for now on exponential equations. In the next video, I will cover logarithmic equations.